Organizing quantitative data. Lesson objectives: organize discrete data in tables, construct histograms of discrete data, organize continuous data in tables, and construct histograms of continuous data. The first step in summarizing quantitative data is to determine if the data is discrete or continuous. If the data is discrete and there are relatively few values of the variable, the categories of the data will be the observations, as in qualitative data. If the data is discrete but there are many values of the variable, or if the data is continuous, categories of the data called classes will be created using intervals of numbers. So let's look at an example. The following data represent the number of available cars in the household based upon a random sample of 50 households. So we're going to summarize this data using a table, actually two tables, a frequency and a relative frequency. In order to do that, we first tally each of these discrete values for the number of cars. We see that 0 cars happen 4 times, and if we get the relative frequency, 4 out of how many? Well, if we add all these up, we know that this should sum 50. So 4 divided by 50 is about 8%. 1 car would be 13, and 13 out of 50 is about 26%. 2 cars is 22. This happens the most often. 22 divided by 50 is 44%. So very quickly, we take what's called the raw data, and we can summarize it in a table, either a frequency or a relative frequency. Lesson objective number 2. Histograms. A histogram is constructed by drawing rectangles. Sometimes those rectangles are called bins for each class of the data whose height is the frequency, or it can even be relative frequency of the class. The width of each rectangle should be the same, and they should touch each other. Now this is different than bar charts. Bar charts, the bins do not touch each other. Histograms, they do. That will tell the reader what type of data. Quantitative data will be histograms. Qualitative data will be bar charts. Let's look at our example for the number of cars in the household. We'll do a frequency histogram and then a relative frequency histogram. So this is going to be our x-axis. This is going to be our corresponding y. So as we can see, and this is known as the midpoint, 0 cars, we have about 4. 1 car is 14, 2 cars is 22, so on and so forth. Now the next slide, this is going to change from frequency to relative frequency, and Minitab expresses this as a percent. So a histogram can be thought of as a visual of the frequency table or the relative frequency table. Lesson objective number 3. Categories of data are created for continuous data using interval of numbers called classes. So here's an example. The following data represents the number of persons aged 25 to 64 who are currently work disabled. So we have the age, and we have the number in the thousands. So this would be a class ages 25 to 34, and there's 2,132 times 1,000 people. The next class would be 35 through 44, and so on and so forth. There's a total of 4 classes here and the corresponding frequency. The lower class limit of a class is the smallest value within the class, while the upper class limit is the largest value within the classes. So the lower class in this example would be 25, 35, 45, and 55. The upper class limits would be 34, 44, 54, and 64. And you want your classes in such a way where they are mutually exclusive. And what that means is a value, a age, can only fit into one class, not the other. So as we notice, this goes to 34, and then 35 starts in a new class. The class width is the difference between consecutive lower class limits, or even between consecutive upper class limits. So for example, if we take 35 minus 25, the lower limits, we get 10. If we take 44, subtract 34, we get 10. So this is how we can compute the class width. Okay, let's look at some raw data involving the student survey. For the early fall term 2009, there was a total of 149 students that took the survey, and we're going to look at the ages. So here's the raw data. It's very hard just to look at this data and get anything from it. The smallest value is 18 years of age, and the largest is 56. Let's say we want to create the classes so that the lower class limit of the first class is 18 and the class width is 3. We start at 18, we want a class width of 3, 18, 19, 20, and then we would start our new class starting at 21 and going to 23. So here's all the corresponding classes, and here's the corresponding frequencies. We can see very quickly that the largest class has a frequency of 40, and that's between 18 to 20, and we expect this because normally in college the students are usually younger. We had 39 between 21 to 23, and if we look at the corresponding relative frequency, we see that about 27% were between 18 to 20, 21 to 23 was about 26%. So between 18 to 23, that is the majority of the students' ages that took the survey. Frequency and relative frequency table allows us to summarize raw data very quickly. Here is a histogram for that frequency distribution. As we can see very quickly visually, these two bins contain the majority of the ages. What we're going to look at next, the next histogram, instead of having what's called the cutoff points. So this would be 18. This cutoff point here would be 21. If we had another student whose ages was 21, that person would fall in this bin, not this bin. 24 would fall in this bin. So these are what we call the cutoff points. Now the next one is what we call the midpoints. As we can see, the histogram changed just a little bit, and that can happen. So you first have to decide, do you want cutoff points or midpoints? So let's go back and look at the cutoff points, and let's look at the midpoints. Okay, let's look if we change the number of classes. Now this histogram has 10 classes, and we can count the bins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 classes here. Okay, so what if we decrease it? We go to 6. See how the histogram shape changes? Let's look at 4 classes. So you have to sort of decide how many classes do you need for your data set. If you have too few, like in this case, we don't get a good summary. If we choose too many classes, then the bins would be spread apart and it's not a good summary of the data. In this class, we will be using technology, both Minitab and StatCrunch. Those programs will determine our number of classes. Let's look at continuous data. This is the histogram for the variable in the student survey data for distance away from school. The variable name was distance_2, and we can see here that the number of classes was automatically determined from Minitab, and it's using midpoints. Now let's look at the histogram where it's the cutoff points, and again it changes shape a little bit. Now if we were to shrink the histogram to 9 classes, this is what the histogram would look like. If we go to 6, again the shape changes as we're grouping more and more data into less bins. So let's summarize histograms and frequency tables. Here's the good things. It helps us summarize raw data. We can easily tell which classes have the largest and the smallest frequency. It gives us a picture of the distribution of the data, and it may help us identify what's called possible outliers. We'll talk more about that in Chapter 3. Now the bad things, we do lose some information by putting raw data into a frequency table or a histogram. You have to be careful about choosing the number of classes because we want to summarize the data and not distort it. Thanks for watching.